Welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about symbols and formulae. In the earlier sessions we have seen about what is symbol, how to give symbol for the element, how are those given, what are the principles to be followed while giving the symbols for new elements. In this session we are going to see about formulae of the compounds. Formula in the sense it is written based upon the name of the compound by using symbols of the elements participating in the formation of compounds. Okay, now let us see here how to write the formula of the compounds. Let us learn it here. The symbolic representation of one molecule of the compound representing the number of atoms of various elements present in it is called formula of that compound. What is formula actually? The symbolic representation. We know for every element a particular and unique symbol is given. And we know how a compound is formed by the combination of two or more elements in a fixed composition ratio. Then a compound is formed. Now this compound will be having a particular name. Instead of writing the complete name, how a symbol is given for the element's name instead of writing complete name, in the same way for compounds also, instead of writing complete name we can use some shortcuts or short way method for representing the name of a compound. The shortcut and a symbolic representation of one molecule of the compound which is representing the number of atoms of various elements present in it is called formula of that compound. Okay, just we can say shortcut or symbolic representation of the name of a compound. For the elements, the shortcut representation, the shorthand representation of the name of an element will end as it is symbol. In the similar way, the shorthand representation of the name of a compound is formula. This formula represents the number of various kinds of atoms present in the molecule of that compound. So this also can be defined as the short form representation of the name of a compound is known as formula of that compound. For example, the formula or the chemical formula of calcium carbonate is CaCO3. So instead of writing calcium carbonate in the chemical reactions often, simply we can represent this with CaCO3. This also represents the same calcium carbonate. Now this CaCO3 is a shorthand notation of calcium carbonate. Now we can say this CaCO3 is chemical formula of calcium carbonate. Okay, this representing the symbolic representation of calcium carbonate, and it is representing the number of atoms of various elements present in it, isn't it? See here, calcium, carbon, oxygen are combined together to form calcium carbonate. And we can understand here how many atoms of each element are present also, isn't it? Right, that is a chemical formula of the compound. We know that English alphabets has 26 letters, isn't it? By combining these 26 letters only, we can make millions of English words. Isn't it? While learning about the English subject or English language, we start learning with alphabets. How many alphabets is in English? There are 26 alphabets only. But now we are speaking English with the uncountable number of words. These all millions of words are made from this only 26 letters with the different combinations, isn't it? In the similar way, in chemistry also, there are only 118 elements. Our scientists they have discovered so far only 118 elements. These 118 elements only they're combining the different combinations on making endless number of compounds. There are crores and crores of compounds are available, but these all are from those 118 elements only. So each compound is represented with an unique formula. How elements are given their unique symbols, in the same way for the compounds also they have, it is given a shortcut notation which is called as formula. So we can get the following information from the formula of a compound. One of them is it tells us which elements are present in a compound. In the earlier we have seen example for the compound formula CaCO3, isn't it? That is a chemical formula of calcium carbonate, we told. See, it tells which elements are present in the calcium carbonate formation. What elements are present? Calcium, isn't it? Calcium, carbon, oxygen. These three elements combined in fixed particular ratio to form this compound calcium carbonate. So that information is given from the formula of a compound. Not only that, it also tells us the number of atoms of each element present in its molecules of the compound, isn't it? Not only what kind of elements present and how many atoms of each element combined also it represents here. Say in the calcium carbonate itself, one atom of calcium, one atom of carbon, and three atoms of oxygen is all combined together to form one molecule of calcium carbonate. So this is information given from the formula of a compound. Okay. So how to read the information from the formula of a compound? If a formula is given, what information we can read from that formula? Let us see that here. The symbols in a formula can be prefixed or suffixed by a numeral. When the numeral is written on the left hand side, that means before the formula, it represents number of molecules of that compound and hence the number of atoms present in the each molecule. Okay, if a number is written in front or before the formula, then that number represents number of molecules of that compound, and we know how many atoms of each element are present in each molecule. So then we can say total number of atoms in that and even how many molecules are there. This information is given when a number is written before the formula of a compound. Okay, compound is refers to a pure substance made up of two or more elements chemically combined in a fixed ratio by weight. Yes, this we have learned already while explaining about the compound and classification of matter. Matter is classified in two types. Chemically, they are pure substances and impure substances. In the pure substances, the substances which are containing same kind of particles in it are called pure substance. And these pure substances again classified into two types. What are those two? Elements and compounds. Elements are the pure substances which are containing only one kind of atoms in it, isn't it? There are 118 elements to, discovered so far. And next, one more category of pure substances is these compounds. Compounds means the pure substances which are made up of only one kind of molecules. Those molecules might be made up of same or different kinds of atoms combined chemically. So a compound refers to a pure substance made up of two or more elements chemically combined in a fixed ratio by weight. Okay. Now let us see some examples to understand this formula concept. When we write 2s or 3Cl or 4Al, it means two atoms of sulfur. See here, this is a symbol which representing element sulfur. In front of this symbol, 2 is written. That represents two atoms of sulfur. And here, this represents three atoms of chlorine. In the similar way, four atoms of aluminium. Okay, in this way, if a number is written in before the symbol of an element or symbol of a molecule or symbol of a formula, so if a number is written before the formula or symbol, that represents total number of atoms or total number of molecules. See here, in front of the molecular formula, a number is written. The second example, when we write 2NaCl or 2ZnO, these represents two molecules of sodium chloride, isn't it? We know this NaCl represents sodium chloride compound. This is a shortcut notation, shorthand notation of the compound name sodium chloride. Now we can say this is a chemical formula of sodium chloride. Before the formula of sodium chloride, 2 is written. This 2 represents two molecules of sodium chloride. Okay, and which contains total number of atoms also you can say from this. 2 atoms of sodium and 2 atoms of chlorine. Isn't it? See the next one. This represents zinc oxide. It is a chemical formula of zinc oxide. And in front of this zinc oxide formula, they mentioned 4. That represents 4 molecules of zinc oxide. From this also we can also say how many atoms of each element are there totally. Isn't it? We can say 4 atoms of zinc and 4 atoms of oxygen. This number will be applied for all the atoms present in the molecule if a number is written in front. Okay, now 4 atoms of zinc and 4 atoms of oxygen are present in this. Okay, next one more point. When the numeral is written on the right hand side bottom of the symbol, it represents number of atoms of that element in one molecule of a compound. So instead of writing at the left hand side or before the formula, if a number is written at the right hand side bottom of the symbol, then that represents number of atoms of that element present in one molecule of that compound. For example, if we see when we write H2 or O2, they mean they means that one molecule of hydrogen has two atoms of hydrogen. And in the similar way, if you see here O2, it represents one molecule of oxygen contains two atoms of oxygen. Okay, this number represents number of atoms of that element present in that molecule. You can see here one more example. When we write SO2, it means in the one molecule of sulfur dioxide, there is one atom of sulfur because here nothing is written. So that represents 1. So one atom of sulfur is present, and here at the right hand bottom side of the oxygen symbol 2 is written. This represents 2 atoms of oxygen are present in one molecule of sulfur dioxide. So in this way, if a number is written at the right bottom side of the symbol of an element, that represents the number of atoms of that element present in one molecule of that compound. So here we can say one atom of sulfur is present and two atoms of oxygen are present in one molecule of sulfur dioxide. Got it? So if you see one more bigger molecule, let us try to understand the same concept by taking one more bigger example. When we write Al2SO4 taken thrice, it is pronounced like this. So here SO4 is kept in the brackets and a number is written here. So it is pronounced like this: Al2SO4 taken thrice. This represents the chemical substance aluminium sulfate. So if it is written like this represents, so at base of the at the right side bottom of the aluminium symbol 2 is written. So it represents two atoms of aluminum are present in this, and these total atoms are present in the bracket and 3 is written here. This 3 will be applicable for all the atoms inside. Now we can say 3 atoms of sulfur and 3 into 4, totally 12 atoms of oxygen are present in one molecule of aluminum sulfate. Okay. See here 2 atoms of aluminium, 3 atoms of sulfur and 3 into 4, totally 12 atoms of oxygen present in one molecule of aluminium sulfate. Okay. And if you see one more example here. When we write 3KNO3. Here, this 3 which is written at the at the front side of the molecular formula will be applicable for all the atoms present in the molecule. So this 3 will come to potassium, and this 3 will be applicable for nitrogen, and this same 3 will be applicable for oxygen also. Now we can say there are 3 potassium atoms and 3 nitrogen atoms. At the same time, 3 into 3, because already here one more 3 is there. So 3 atoms, and there are 3 molecules. So this 3 into 3, totally 9 oxygen atoms are present in this given substance 3KNO3. So this KNO3 represents one molecule of potassium nitrate, and before this 3 is mentioned. That represents 3 molecules of potassium nitrate. So now if we say total number of atoms, the 3 written front should be applicable for all the atoms. So it becomes 3 potassium atoms, 3 nitrogen atoms, and 9 oxygen atoms. Got it? Now let us see formulae of some common compounds which we use in the general life, general science studies. Hydrochloric acid, which is one of the familiar acids. Its formula is HCl. Nitric acid HNO3. Observe once the formula of the common compounds given here. Sodium chloride, which we use regularly, NaCl. Okay, these are certain compounds with their chemical formula. Have seen this? Let us go to next. The significance of a formula. While learning about symbols of elements, we learned the what is the significance of symbol of an element. How a symbol has two significances. In the same way, formula also has two significances. One is a qualitative significance and the other one quantitative significance. First about qualitative, what information is given qualitatively from the formula. Qualitatively, it represents the type of elements present in it. What kind of elements are present in it is given by formula of a compound. For example, if you see the chemical formula of calcium carbonate is CaCO3. It represents, it contains calcium, carbon, and oxygen as the elements. So this is the information. This is the qualitative information from the formula. Qualitative information means what kind of elements are present in the formation of calcium carbonate. The elements participated in the formation of compound is this information is given from the formula of a compound. This we say as qualitative information. If you see example calcium carbonate, it is one compound. So its formula is CaCO3. If you write CaCO3, it gives qualitative information as it is made from calcium, carbon, and oxygen elements. Okay, and if you see the second quality, that is a quantitative information, that means a quantitative significance. So quantitatively, a formula represents the number of atoms of each element present in one molecule of the compound. So we have seen qualitative information means what kind of elements are present. By coming to quantitative information, it tells us about the number of atoms of each element present in the molecule. If you see the same again, CaCO3. From the formula CaCO3, we can say one atom of calcium, one atom of carbon, and three atoms of oxygen combined chemically to form one molecule of calcium carbonate. That is a quantitative information. How many atoms are combined? Which atoms are participated? That is qualitative information. How many atoms of each element are participating in the formation of molecule? This is quantitative information. In this way, from the formula of a compound, we get qualitative and quantitative significances. Right? Next, let us see how to write the formula of a compound. If you know the symbols of the elements, by using the symbols, how to write the formula of a compound, let us try to learn here. To write the formula of a compound, we have to follow certain steps. This method of writing the formula of a compound by following certain steps is known as crisscross method. So let us see here what steps to be followed in writing the formula of a compound by using crisscross method. The first step in this is write the symbol of the positive ion followed by negative ion. So first we have to write symbol for the positive ion followed by negative ion. Okay. So here that ion might be either single atom ion or a radical also, whatever it might be. First we write positive ion or radical followed by negative ion or radical. Then put the valency number of each radical or the ion on its top right. So we have to mention the valency also. After mentioning the valency of each ion or radical, we have to eliminate the common factor from their valencies. Or simply we can say divide the valency numbers by highest common factor if any to get the simplest ratio. Or we can say eliminate the common factor from the valencies of both ions. Now we have to ignore the positive and negative symbols in those charges. And then we have to interchange the valencies numbers on the radicals or ions. Then in the third step, shift the valency numbers to lower right side of the radicals or ions. That means crisscross the valencies. The valency of first ion is written at the right bottom of the second radical or ion. The valency of the second radical or ion is written at the right bottom of the first ion. This is called crisscrossing. If the radical receives a number more than 1, radical means the ion formed by more than one atoms. We have learned already. So if a radical receives a number more than 1, then we have to enclose this radical with a bracket before writing that number. Okay, if it is an ion, need not to enclose with the brackets. Okay, these are the three steps which we have to follow while writing the chemical formula of a substance. Let us recall once the steps. First, we have to write the positive ion or radical, which is followed by negative ion. And then we have to mention their valencies on the right top. Next, we have to eliminate the common factor from their valencies or divide these two valencies with the highest common factor to get the least ratio. And then we have to ignore the symbols, positive and negative symbols in their charges. Then after that, with the remainder numbers after elimination of common factor, we have to crisscross those. Then we get the formula of the compound. Why after crisscrossing, if an ion, if a radical gets the number more than 1, then we have to keep that in the bracket before writing that number. Okay, these are the steps we have to follow while writing the formula of the compounds. Let us try to understand these steps in writing the formula of a compound by taking certain examples. See first example, let us try to write the molecular formula of aluminium chloride. So here positive ion is from aluminium, negative ion or anion is from chloride ion. How do we know? By knowing the atomic numbers of these elements. We know aluminium atomic number is 13, isn't it? So if you write the configuration, what we get? 2, 8, 3. So in its valence shell, it has 3 electrons. To become stable, it will lose that electron and forms Al plus 3 ion. So this is positive ion in this molecule. Okay, Al plus 3. And next if you see chlorine, what is the atomic number of chlorine? 17. If you see its electronic configuration 2, 8, 7. In its outermost shell, it has only one electron. To become stable, it requires one more electron. So, by gaining that electron, chlorine becomes Cl minus ion. Now, here positive ion is Al plus 3, negative ion is Cl minus. So, now let us try to write the molecular formula of this compound by following crisscross rule steps. What is the first step in that? Writing the positive ion followed by negative ion. So it is written here. Al plus 3 and next Cl minus. Next, step 2, we have to eliminate the common factor if there any from these charges. See here, the charge is 3, here 1. No common factor. No common factor can be eliminated from these two. So that's why they are written as it is. And we have to eliminate these positive and negative symbols from their charges. Just the numerals are taken. After writing like this, after the elimination of common factor if any, we have to, in the third step, we have to crisscross these numbers. See the third step, we have to crisscross the numbers remained. This 3 is written at the right bottom of Cl and this 1 is written at the right bottom of the aluminum symbol. If it is 1 for an ion, need not to mention it in the formula. So actually we get it as Al1Cl3. But if it is 1, need not to mention. Okay, now the formula of this compound will be AlCl3. The chemical formula for aluminum chloride is AlCl3. Did you understand how to write the molecular formula? By following crisscross steps. First, we have to write the positive ion followed by negative ion. In the second step, we have to eliminate the common factor from their valencies, if there any. After the elimination of common factor, we have to ignore the symbols of those charges. Then we have to crisscross the numbers. Crisscrossing means the valency remained on the second ion should be written at the right bottom of the first ion. And the valency of the first ion remain should be written at the right bottom of the second ion. If one of these ions, if it is radical, then if it is getting the value number more than 1, then that radical should be kept in the brackets. Okay, in that way we can derive the molecular formula of a chemical compound. Let us see one more example. See here, writing the molecular formula of magnesium sulfate. So what we have to know first for writing magnesium sulfate molecular formula? The positive ion form symbol and negative ion symbol. Here positive ion is from metallic element, that is magnesium, and a sulfate radical. We know sulfate radical formula is SO4 minus 2. Okay, this is sulfate radical. Now let us see the ion formed by magnesium. We know atomic number of magnesium is 12. So if you write configuration, what do we get? 2 comma 8 comma 2. This is a electronic configuration of magnesium. Is it a stable element? No, because it has only 2 electrons in the valence shell. To become stable, magnesium loses these 2 electrons and hence becomes stable with the 2-8 configuration. So by the loss of 2 electrons, magnesium forms now Mg2 plus ion. So in this way, the ion formed by magnesium is Mg2 plus and the sulfate ion is SO4 2 minus. Now let us try to write the molecular formula of the compound formed by magnesium and sulfate ions. In that, first step is writing positive ion followed by negative ion. It is written. Say first Mg plus 2 ion is written and next SO4 minus 2 ion. Both are written. In the second step, the common factor should be eliminated. See, this is also having 2, this is also having 2 in these charges. Common factor 2 can be eliminated. Now it becomes Mg1, Mg plus 1, SO4 minus 1. Then we have to neglect the charges of the symbols plus and minus. Now it becomes Mg1, SO4, 1. After eliminating these charges and common factor, now we have to crisscross these numbers. The one from the sulfate ion should be written at the bottom of the magnesium ion, and one from magnesium should be written at the bottom of the sulfate ion. Now see the step 3. What do we get? We get here as Mg1 SO41. If it is 1, need not to mention in the formula. So thus the molecular formula of the compound magnesium sulfate is MgSO4. Okay, in this way we can write the molecular formula of the compounds by following the rules in crisscross method. Got it? Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates and recorded videos. And even visit our website aimstoday.in for these all recorded videos. Thank you.